Have you ever wondered what would happen if the moon suddenly disappeared? Imagine one fine night you look up to the sky and find that our beloved moon has vanished. Poof! Gone without a trace. This is not a scene from a science fiction novel, but a hypothetical scenario we're exploring today. The moon, our closest celestial neighbor, has always been more than just a beautiful ornament in the night sky. Its influence extends far beyond its luminous presence. The moon's gravitational pull plays a significant role in our day-to-day lives, though we may not always realize it. As Earth's only natural satellite, the moon exerts a powerful influence on our planet's rotation. You see, our planet spins on its axis, completing a full rotation approximately every 24 hours. This rotation, combined with the moon's gravitational tug, results in the familiar cycle of day and night we experience. But the moon's role doesn't stop there, it also impacts our tides. The gravitational pull between Earth and the moon causes the oceans to bulge out in the direction of the moon. This bulging, coupled with Earth's rotation, results in high and low tides. Coastal communities, marine life, and even our climate are significantly influenced by these tidal patterns. Without the moon, these familiar rhythms of life would be thrown into chaos. Our days would become shorter, the oceans would become calmer, and the nights would be darker. We'd be living in a different world, both literally and figuratively. But don't start panicking just yet. This is purely a hypothetical situation. Our moon isn't going anywhere anytime soon. However, exploring these what-ifs can offer us an intriguing insight into the intricate cosmic dance between Earth and its moon. Now let's delve deeper into the implications of a moonless Earth. The moon's gravitational pull is responsible for our tidal patterns, but what happens if this pull ceases to exist? The moon, our celestial companion, exerts a gravitational force on our planet, and this force is a key player in the dance of the tides. When the moon disappears, this gravitational duet comes to an abrupt halt, and the repercussions of this sudden stop are far from trivial. The moon's gravitational pull causes the oceans to bulge out in the direction of the moon. This bulge, along with a corresponding bulge on the opposite side of the Earth, results in 2 high tides and 2 low tides each day. Remove the moon from this equation and the tidal patterns we're accustomed to would shift dramatically. Without the moon's gravitational influence, the sun would become the primary driver of our tides. However, the sun is over 380 times further away than the moon, and its gravitational pull on the Earth is less than half as strong. This would result in much smaller tides than we're used to, leading to a calmer sea on the surface. A calmer sea might sound like a sailor's paradise, but it could spell disaster for marine ecosystems. Many marine species rely on tides to breed and feed. Coral reefs, for instance, depend on tidal movements to flush out toxins and bring in nutrients. Without the usual ebb and flow, these ecosystems could face significant challenges, potentially leading to a decline in biodiversity. The effects would not just be limited to the oceans. Coastal areas would also be affected. Many coastal ecosystems, such as mangroves and wetlands, rely on regular tidal flooding. A change in tidal patterns could disrupt these delicate habitats, with potentially devastating consequences for the plants and animals that call them home. In a world without the moon, our oceans would become a very different place. The tidal turmoil would bring a sea of changes, quite literally, to our planet's marine and coastal ecosystems. But the change in tides is only the tip of the iceberg. Without the moon, Earth would be a wobbly planet with chaotic weather. Now let's delve into this a bit more. The moon, in its silent orbit around our planet, does more than just light up our night sky. It acts as a stabilizing force for Earth. You see, the gravitational pull of the moon helps to maintain our planet's axial tilt at a steady 23.5 degrees. Without this stabilizing influence, Earth's tilt could vary wildly, leading to extreme climate changes. Imagine our planet wobbling on its axis, its tilt shifting drastically over time. This would cause seasons as we know them to be thrown into disarray. Summers could become unbearably hot, winters unimaginably cold, and the transitions between seasons could happen in the blink of an eye. Our planet's weather patterns would become unpredictable, to say the least. This isn't the plot of a science fiction novel, it's a potential reality if the moon were to suddenly disappear. Our world's climates would shift drastically and unpredictably. We'd see extreme weather events, from scorching heat waves to bone-chilling blizzards, become the norm rather than the exception. The moon's absence would turn our planet into a topsy-turvy world of extreme and erratic weather, where adapting to the ever-changing climate would be a constant challenge for all life on Earth. It seems the moon plays a pivotal role in maintaining our planet's stability. Imagine a sky without the moon's glow and a world vulnerable to space debris. Under the moon's soft luminescence, the world takes on a different character. Nocturnal animals rely on its light to hunt, navigate, and carry out their nightly activities. Imagine the profound impact on these creatures if the moon were to suddenly disappear. The darkness would be disorienting, disrupting life cycles and survival strategies honed over millennia. Moreover, the moon's absence would extend beyond the animal kingdom and into our human activities. Without the moonlit nights, our ancestors would not have ventured out after sundown. Today, we continue to rely on the moon's light for nighttime navigation in areas without artificial illumination. The world would indeed be a darker place, both literally and metaphorically. But the implications of a moonless sky stretch even further. Our moon serves as a guardian, shielding us from the constant barrage of space debris. Without its gravitational pull, we would lose this protective barrier. The result? An increase in meteor showers. Now, while this might initially sound like a spectacular light show, the reality could be quite disastrous. The influx of meteors could pose significant threats to our satellites and even to life on Earth. Evidently, the moon's disappearance would have far-reaching implications, some of which we might not even be able to predict.